Okay, so time for a bit of physics fun. We're looking at transmission lines. Now we've got a whole circuit set up here. Let's just go through what it does. So we've got an AC power pack on 12 volts. Not DC, we're using AC. It has to be alternating current for the experiment to work with a transformer. Light bulb connected to tap off here. And we've got the two transmission lines that are simulating my national grid cables. And I've got two wires and a bulb for output. Let's just see what happens then. So I'm going to switch on. We've got one bright bulb. Oh, and unfortunately, the energy here is really small. It's not delivering what it should do. There's an equation for that. Power loss is I squared R. So the higher the current is, the more the power loss will be. So if I use a transformer to reduce the current flow, I should reduce the power. Now, if I reduce the current by a half, because it's a squared term, the power loss will be a quarter. So what I'm trying to do is reduce current and increase potential difference. And of course, power is V times I. So if one goes up, the other has to go down. Now this equation here, I can change my voltage or potential difference effectively using a primary and secondary transformer and changing the number of turns. So we have one transformer at this end, and now I'm going to attach my transformer in. Let's put that in there. So now we've got what's called a step-up transformer. So this will increase the potential difference, reduce the current. It will flow along here. There'll be less heating of the wire, so we should lose less current. And then at the end, we want to step it back up again to 12. And so we've got 12 volts and a decent amount of current in the bulb. Sorry, I did mean step up the current. So here we go. I'll get everything in. Hold on. Here we go. Oh. So clearly now, this is a nice and bright bulb, and this is a nice and bright bulb. And if I had an infrared heat detector, I would see that in the wires, they're not getting as hot, and they potentially won't sag as much, which can be a problem with heated wires, and I have more energy delivered, which is what I want, using a step down and a step up transformer. Now, of course, in the national grid, this could be very dangerous because this could be thousands and thousands of volts potential difference, which can easily spark. Here, it wouldn't be as much, but I'm still not going to touch it because it could be quite high and it could spark and hurt me. So there you go, transformers and transmission lines.